Topic for today's video is one of the most prominent topics in generative AI, that is Vector DBs, that is vector database. In this video, we'll be introducing what exactly is meant by vector DBs. Then we'll be discussing the key characteristics of vector DB. Post that, we'll be delving in how the vector DBs work. What is the workflow of a vector DB? Then we'll be discussing a few use cases that can be solved using the power of vector DB, or how can we leverage vector DB to solve a certain business use cases. Then we'll be discussing what are the popular types of vector DBs today in the market, which can be leveraged by the end user. Lastly, we'll be leveraging vector DBs to solve a business use case practically in a Python environment. Let's start by defining a vector database. A vector database is a specialized type of database designed to store, index, and query high-dimensional vectors efficiently. What exactly is the meaning of vectors or vectorization? Vectorization with respect to natural language processing is a process of converting natural text or raw text in a form of numerical array, such that similar words are kept closer or are placed closer in the continuous vector space. For instance, if I want to vectorize or I want to convert these particular four words in vectors with respect to the seven characteristics, that is number of eyes, number of limbs, fitness, can speak, area, government present, and longitude. These are the seven characteristics, and I want to vectorize each of these four words with respect to the same seven characteristics. What I find is the vectors of Ronaldo and Virat. Since these two are athletic personalities and they are human beings as well, their vectors are placed closer to each other. Their vectors are very similar to each other. Hence, the distance between these two vectors is also closer. But when I compare Ronaldo to Brazil, the vectors of Ronaldo in Brazil are very different from each other, because Ronaldo is a human being, whereas Brazil is a geography present on the globe. On the other hand, if I compare Brazil and India, which two are also countries present geographically on the globe of Earth, the vectors of these two, since these two are countries and similar to each other, the vectors of these two are similar to each other. Hence, the distance between these two vectors is also closer. This is what is meant by vectorization or word embeddings. To learn about word embeddings in depth, please refer to my video on word embeddings. Since we cannot use raw data in the form of natural text or images or videos directly as an input to a machine learning model or an artificial intelligence model, we have to convert these raw data, be it natural text, images, or videos, into a form of vector, that is numerical array, so that it can be fed as an input to these particular models. The process of vectorization is not only limited to natural text, it can be extended to any data, any input data that can be encoded into the form of vectors. That means images, videos, or any other type of data which can be encoded in the form of numerical array can be vectorized. Now, coming to the characteristics of vector database, there are three prominent characteristics of vector database, namely high dimensional data. The second one is efficient indexing, and the third one is similarity search. Now let's try to understand these three characteristics in depth one by one. Coming to the first characteristic of a vector DB, that is high dimensionality. It means that instead of us converting these four words in the example that we just saw for vectorization, to understand vectorization, we converted each of these four words in a vector of seven characteristics. These seven characteristics were eyes, limbs, fitness, can speak, area, government, and longitude. Hence, we have had an array of seven numericals or seven characteristics. This characteristics can also be said as seven dimensions. If we want to have a more accurate vector or a more accurate word embedding with respect to each and every word, we need to increase the dimensionality or increase the number of characteristics with which we create a vector for each and every particular word. Let's say we, instead of having a 7-dimensional vector for each word, we had a 500 dimensional vector. This is what is meant by high dimensionality, that vector DBs can store high dimensional data, that is natural text or any input data that can be converted into form of array of numericals. It can store big vectors or high dimensional vectors, is why it has one of its characteristics of high dimensionality. Now coming to the second and third most important characteristic of a vector DB, that is indexing and similarity search. Let's take an example that we have a book. To understand indexing or what indexing is, let's take an example that we have a book related to the functioning of mind or a human brain. I ask you to give me some information regarding what happens in the human brain when a human being takes tension. Whenever a human being takes tension, what happens to the human brain? Based on the particular book that I have given to you, I want you to find out about that particular topic. Let's take an example. If that particular book does not have the first scenario, the book on human brain does not have the contents page in it. What your approach would be, you'll have to go through the whole book page by page, one page at a time, and search for this topic of tension in the whole book. You're lucky if this particular topic comes in the initial part of the book, or else you'll have to go through the whole book, and there is a chance that in a hurry you might even miss that particular topic or don't get the exact information. Whereas in the second scenario, if I have given you this particular page of contents, or that particular book has this page of contents, what you will directly do, your approach will totally change, wherein you will directly search for this particular topic of tension, and you found it at the 22nd index. You directly went to the page number 200, which you see that this particular topic is present over there, and fetch out the required details. Which way is faster, first or the second? Obviously, second. This is what is meant by efficient indexing, which helps to enhance the process of searching. That is decreasing the time of similarity search. Over here, the similarity search was, I wanted to find a topic in the whole book related to tension. I wanted to have that information regarding tension in the whole book that contains 264 pages. Instead of going page by page on searching the topic, if I had a index created or a content page created wherein I directly find that particular topic and refer to the page where it is present, I'll save a lot of time. The latency will decrease and I'll have a better result in time. This is the same indexing that happens in vector DBs as well. Let's take an example wherein I have made a vector DB with respect to a documentation on wildlife. Wildlife has many type of animals present. There is a documentary, a corpus containing thousands of documents, of which I have created a vector database of. In this particular example, what I want to have the information about, let's say, lion, specifically lion. Now, instead of going through the whole 1000 PDFs that I have in the corpus, if I store that into vector DB, I'll have an efficient indexing that happens. Indexing as in, the vector DB will divide all the animals into subcategories for efficient indexing, that is mammals, reptiles, amphibians, birds, separately, indexing them separately, so that when I ask about lions specifically, instead of going through all the data, that is all the corpus or all the words or the sentences in the 1000 PDFs, I'll directly go to the mammals space of the index, and in that index also there is a sub index of cat family. Instead of going through all the mammals one by one, even that time is spared, and I directly go to the cat family and fetch out the details for lions. This is what is meant by efficient indexing and similarity search. Similarity search means finding the similar topic with respect to the query that you have efficiently, getting the similar information with respect to a query that the user has. These are the two characteristics of vector DB. Coming to the working of vector databases, there are majorly 3 steps involved. The first one is converting the raw data or the raw input data, be it in the form of natural text, images, or videos, into the form of vectors, because the raw input data cannot be directly used as an input to AI or machine learning models. Hence, it has to be converted into a form of vectors or arrays of numerical data. That is the first step, that is converting raw data into vectors, high dimensional vectors. The second one is efficient indexing. These high dimensional vectors are then indexed using specialized data structures that allow for efficient similarity search. Coming to the third step, that is querying. Once the user asks its query with respect to a particular vector database, that particular user query is again converted into a vector representation, and the database uses its indexing structure to quickly find and return vectors from the vector database that are most similar to the query vector to get us the most similar results in as much as less time as possible. We will see each of these steps practically when we move to implementing a use case in Python notebook later on in this video. Now let's discuss some of the most prominent use cases of vector DBs, starting off with their applications in machine learning and artificial intelligence. They are used in image recognition for storing image embeddings to find similar images. They can also be used in natural language processing for tasks such as semantic search or text classification. They're also used in recommendation systems to find similar users or items based on their vector representations. Like in OTT, that is Netflix or Amazon Prime, they suggest similar users, similar kind of movies. Coming to the next one, that is their uses in retrieval augmented generation in Gen AI, that is document Q&A and domain specific, creating domain specific chatbots. Vector DBs can also be used in bioinformatics for analyzing high-dimensional data such as gene expression profiles. They can also be used in e-commerce industry for product similarity search to enhance user experience by recommending similar products or customized user experience. These are some of the most prominent and popular vector DBs in today's generation. The first one is FAISS by Facebook. The second one is Finecone. The third one is ChromaDB. Fourth is Elasticsearch. The fifth one is Milvus. And the sixth one is Grant. Coming to the last part of the video, where we'll be trying to learn how to implement a use case using vector DBs in a Python environment. For this use case, we'll be using FAISS CPU, that is FAISS Vector DB for indexing, and Mini-LM model from Hugging Face for converting the natural text or the raw input data in the form of natural text into vectors for vectorizing the input data. Hence, we'll be installing these two libraries. Post that, we'll be setting up a Hugging Face token. The reason is we want to load the sentence transformer model, that is our Mini-LM model, which will help us vectorizing our input, raw input or the natural text. Then we'll be creating a artificial corpus of data or a list of sentences. Let's say the list of sentences that we have as our corpus are: I love programming, artificial intelligence is fascinating, the weather is nice today, I enjoy reading books on machine learning, Python is a versatile programming language. This is our whole corpus or the list of sentences that we have initially. Post that, the first step in our process that we learned theoretically was converting the natural text or the input text in the form of embeddings or vector representation of those. Since we already have the model for converting natural text into word embeddings, that is Mini-LM model loaded, what we'll do is we'll encode each of these 1, 2, 3, 4, 5 sentences. We'll encode them into vector embeddings, or we'll have a vector representation of all of these. That is converting natural text into array of numerical data. For your reference, I have printed what an embedding of these 5 sentences look like. The shape of this is, since we have 5 embeddings, there are 5 arrays of length 384 each. That is, the dimension of each and every embedding is 384, a length of array of length 384. The next step after we have done the vectorization is creating a vector DB index. Over here, since we are using FAISS index or the vector DB, we'll be creating an index using that. and post that the embeddings that we had created for these 5 sentences or the input data, we'll be adding those embeddings into the FAISS index. The last step in our particular journey is querying or the querying the index with a new sentence. Problem statement over here is I want to find the top 2 similar sentences with respect to this query sentence or the input sentence. That is, I like coding in Python. Of the 5 sentences that we had given earlier and stored in the FAISS index after converting them into embedding, I want to find of those 5 sentences which are the top 2 similar sentences with respect to this sentence, that is, I like coding in Python. The first step in that would be I'll again encode this particular query sentence, into a form of word embeddings, or I'll vectorize this. For your reference, this is how the embedding would look after I have encoded it using the same word embedding model. The shape would be, since I have one sentence, 1, 384. The length of the embeddings would remain the same as we had when we were embedding the input 5 sentences. The next step after encoding the query sentence into vectors or word embeddings of length 384, we'll do a search in the index for the nearest neighbors. We want to search that which of the sentences are similar to I like coding in Python. Sentences similar in the input corpus of 5 words that we have given. We want to find the similarity between the query sentence I like coding in Python and the input corpus of sentences, 5 sentences that we had given. And we have stored them in the FAISS index. Since I want top 2 similar sentences with respect to the query sentence, I have given the K, that is a hyperparameter, saying that I want 2. I have mentioned it as 2. I want 2 similar sentences or 2 nearest neighbors to the query sentence. Suppose that I pass K2 and the query embedding as the input to the search function of the index, FAISS index. Then post I get the output, I try to print it using a for loop. The output says that the top 2 similar sentences to the query sentence, that is, I like coding in Python, the top 2 similar sentences to those are Python is a versatile programming language and I love Python. I like programming. Of the 5 input sentences that we had given, these are the 5 input sentences. Of these 5 sentences, these are the 2 similar sentences to the query sentence that we had given. So summarizing the whole thing, all the steps, the first step is the input corpus that we have over here. Let's say we have 5 sentences as the input corpus. We convert them into vectors. After converting them into vectors, we create a vector DB or a indexing function. Over here, we are using FAISS, right? We define FAISS index. Suppose that the embeddings that we had already created for the input corpus, we add those embeddings into the index, FAISS index. The third step is we try to query the index with a new sentence. Over here, we have the query sentences, I like coding in Python, for which we want to find the top 2 similar sentences from the 5 input sentences or the input corpus that we have stored in the index already. To do this, we convert this particular sentence also in a vector, high dimensional vector space of 384 numericals, and then we search the index for the nearest neighbors to this particular embedding, giving a hyperparameter of 2, since we want the top 2 similar sentences with respect to the query sentence that we have referred earlier.
Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.